now. Welcome to this session.
This presentation explores DTN's approach to delivering world-class weather intelligence, showcasing how they transform raw data into valuable visualizations for clients, using advanced technologies and techniques, from data processing with Python to geospatial mapping. With over 20 years of experience serving Fortune 500 companies, our next speaker brings a unique blend of applied physics and business management to his role. Aside from being a seasoned enterprise solution architect at DTN, he's also a prolific artist and a published author with ABS-CBN books. Let's give a hearty hello to Mr. Ryan Sondagon.
Hello everyone. Thank you. Much energy with that introduction. I hope I could live up with that. So let me share my screen. And then without further ado, yeah, let's start. So welcome to the Weather Intelligence and Beyond, from sourcing to visualization. A bit of mouthful, and that's because it's truly a large topic to cover. No? And by saying large, I'm kind of foreshadowing yung big data discussion later on. So to you guys, mga engineers and data scientists there will be a lot of discussion with big data. Hopefully, I could cover a lot of topics, even the detailed one, but it's going to be a high level discussion on why weather is actually a big data system. No? Um, so who am I? I think the introduction provided a very good intro on who I am. But I could probably just a shameless plug. So yeah, I'm actually a graduate of BS Applied Physics in National Institute of Physics in UP Diliman. I spent my academe working on quantum wells, simulation for quantum wells. So somewhat related with what we have right now. It used to be called, I think, deep learning neural networks, and now it's actually AI with the boom, no? AI. You'll find a lot of topics here, mostly with AI. And some shameless plug, I'm also a professional painter. I work with, if you go to the HBO, work with director Eric Mati on the job. So that's my painting, and work with Vice Ganda on her book, Totoy. So try to buy those books, try to support our industry. So yeah, how's the weather? This is somewhat I would say, unfortunate question to be asked nowadays, especially in the Philippines. We did have Typhoon Julian, remember, about 2 weeks ago, I think, and in the counterpart in the U.S., they did have Helen and Milton. I think just last week, no. So if you watch the news, you've probably seen Florida being, bombarded with this category 3 hurricane. So if you think about it, if someone asks you how's the weather, it's usually followed by somewhat depressing answer now. So during these times, especially September to October, the Philippines, I think we receive about, I would say, around 12 na typhoons a year natin, and mostly would be in September and October. So in the US, it's also a hurricane season from August to October. Um, so let me provide you some data. I think that's very helpful on why this particular concern, disaster, is very helpful to all of us now. So according to NOAA, that's National Oceanic and Atmospheric Administration. So don't be confused with NOAA, NOAA, with our NOAA. No? So in the Philippines, we have our NOAA, which is Nationwide Operational Assessment Hazards. Most of providing the hazards whenever there's a typhoon. Na. But according to NOAA, from National Centers of Environmental Information, so that 2020, during the pandemic, imagine during the pandemic, it was truly a year of extreme. So the estimated cost of US billion dollars for the years 2016 2020. Within that 4 years, it exceeded about $600 billion. So if you try to put that into perspective in the Philippine settings, uh, $600 billion. If you compare that to our GDP for the 2024, our nominal GDP amounts to 420 billion. So that's more than what we actually generate within the year 2024 for our GDP. So it's a big loss, a big money. And if you point to Philippines perspective, we also have our own misfortunes now, and we usually name them against the typhoons that actually we received all throughout the years. And of course, all of you, most of you would be familiar with Haiyan, Yolanda. About a decade ago na rin pala, no? And it amounted to about $2.2 billion of that's actually the cost. um, of course, if you're thinking about cost, syempre monetary, but what's more unfortunate, I would actually, and all of you would agree, would be the numbers of lives lost. No? So Yolanda, there were about 6,352 people who lost their lives. So would it be nice if, for example, if we ask how's the weather, would it be nice if there's actually a tool that we could say there's a forecasted hurricane, but we've planned for it. So try to think of it that in that perspective, if we were actually notified, na-inform tayo, mga ganun. And that's why I'm working with DTN now. Yan, so Nux DTN. It's actually a company I'm working on. And it's a bit cringe-worthy. In DTN, we save lives. So I'm quoting myself on that na. It's cringe-worthy, worthy for the link and post siguro. But it's a hill I'm willing to die on. Because for me, I experienced it firsthand. No, while working in DTN about a couple of years ago, about 2022. Yeah. And I was fortunate enough to work with one of the European weather room tool. We called it MeteoGuard weather room tool. And we provided almost real-time solution via WebSocket. So it's a simple solution. As a software engineer or as an architect, we just implemented as WebSocket, make it almost real-time. And then about 2 weeks after that, the end of the sprint, the product owner went back to us, and he read yung mga comments coming from the customers, so direct customers. And by the way, weather room tool is exactly a tool being used by the meteorologist, and it provides notification to customers na the incoming storm, something like that. And in this particular case, the I would imagine she's an old lady. She was about to drive daw out of her house, and she got a notification saying that there's going to be a snowstorm, incoming snowstorm, and it won't be it won't be safe to drive. So in her reaction, she felt that we kind of saved her lives, and in reality, I think we did. Na. So and if you talk to some of our folks in DTN, they have some anecdotes and stories on how they save lives. Na. So and you're probably wondering how we provide this now. So DTN, we provide solutions in the different sectors. We have agriculture, we have fuel, we have aviation, maritime, sports and safety, transportation, and energy, among others. And in the Philippines context, I think all of this industry relatable na. And one of, I think, uh, I would say related. I think last week was it the yung concert. We have an open door concert. No, in the US they do have this particular, especially in sports and safety. They want to be notified about the lightning, incoming lightning. And if you imagine lightning, it's quite fast now. So more on it later on. But if you imagine, they need to provide to have at least a forecast on a few hours before the lightning strikes on their area, which is reasonable because you don't want to have your your athletes doing some sports and then being infected by lightning. And we the same case in Australia, we have a weather zone in our case, and most of the utility worker whenever they work on the akit ng pole, and I think it would be very helpful in our case sa Meralco mga ganon. There's a lightning incoming, they're the first victim because they're actually climbing the poles. No? That's happening in weather zone, one of our projects in DTN, and so on and so forth. It's a vast solutioning for different industry. I think for the Philippines context, most of us have in maritime, no, marami marino. It's really helpful to be notified if there's going to be a typhoon incoming for a specific region sa dagat, so in the ocean. So I'd like to share some of the innovation and just to highlight on what we do now. I love the innovation that we have with DTN, and somehow I think it could relate to your industry as well on how to find solutioning now. So in this particular story, last September 12, we were featured by Tamliamas, top story with Tamliamas in NBC, and as you can, yeah, if you read the caption, self-driving technology may improve forecasts. So it's really innovative in a way that we're getting the innovation from a different industry, and in this case, the self-driving technology, and putting it in the forecasting system for our model, so model prediction. So as you can see, it might be a bit need to zoom in for this, but what we did here is uh, I would say typically model blends. What it means it's there are multiple models. You forecast several model runs, and you try to blend it to provide much more I would say detailed and precise forecasting for a particular typhoon. So in our case, what we did is we used what we call the semantic segmentation from the self-driving technology, and and what we found out, actually, Dr. Sam, our meteorologist, was able to spearhead this. He found a lot of details have been smoothed out with the usual practice of model blending. So what we did in our part, we used that particular technology, this semantic segmentation, and then we found out that there are a lot of I would say details that are kept. So if you take a look at this comparison, the eye of the storm is shown in the DTN, while in the model blend it's not. So it might be, you might say, it's is it really helpful? For those people that will be affected by that particular region, it will be. Kasi yung risk assessment mo, tatamaan ako. I'll be hit by the eye of the storm. That's gonna be different with something like, oh, it's gonna be an average measure. The risk would be similar to other regions. So this is particular one of innovation that we have, and later on I'll provide a use case on related to self-driving technology, different industry as well, on how we use it and adapt it to our forecasting system now. Um, so this is actually quite new, and again, Hurricane Milton. Uh, in particular, DTN provided an outage forecast. I think about 2 months or prior, um, and as you can see, the granularity. You could see that this particular region of Florida would be out of power. Definitely would be out of power once the typhoon hits you. So if you live somewhere here or in the orange or yellow region, at least you'll know that you could probably provide some resource planning and risk assessment and restoration of the power itself. No? So that's how granular and how important it is. Um, and then if you think about it, the operational intelligence, it all falls down to the weather data. No? So if I later on, I'll provide you why weather data would be a big data. But let's first see what weather data looks like. No, so if you talk about what weather data, these are the weather data coming from different measuring instruments. Um, we have surface observations, we have satellite imagery. So again, from the satellite, we have radar data, we have radiosonde data, uh, upper air data, and then we have wind profilers, aircraft observations, river gauges, and last but not the least, my favorite, simply looking outside. So if you go outside and you see the weather, you could, as the meme, the picture itself, you could wet your index finger. You could be a walking air vein. Um, but simply put, it's a lot of data come from different sources coming at different times. It's gonna be, a big data. big data problem. And that's a good thing, because once you've identified that whether data is a big data, you'll be able to provide solutioning for in such a way that we do have, multiple references resources for big data. No? So engineers at DTN estimate that its global forecast engine processes petabytes of data, petabytes uh, per day. So petabytes is 15 zeros, 15 zeros. So try to imagine per day. So that's how big it is, no? And but since we do know na big data siya, we could categorize the challenges, no? So I think a lot of you guys are data scientists. Some of you have handled a big data. It's often I think the initial part of how to solution the system is to identify the source data itself. So you could categorize yung challenges with regards to volume. You could categorize it with regards to velocity and variety. So volume, I presented it earlier. It's going to be 15 zeros, petabytes per day. That's huge. And the velocity, for example, the one I referred to, for example, lightning, if it's going to be incoming, almost parang milliseconds, no? It hits the particular region, it gets read by the instrument, gets thrown to the ingestion, so on and so forth. So that's how fast it is. Some of the raw data would come in, say, a forecast for a 1 week forecast. So at least for that, you do know how the particular frequency for handling those systems. But for lightning per se, it's gonna be really quick, no, almost streaming. Variety, as I mentioned earlier, is gonna be different. If you have the radar reading, it could be a raster image provided globally, globally, and you could have grid files. Some you could have in JSON, XML. So think of it as some would be structured, unstructured. Some would be semi-structured, and again. I'm sure a lot of data scientists are thinking data lake, mga ganun. But yeah, more on to that later on. So high level, if you're thinking about this particular three V's of challenges now, we could provide solution for all of this in terms of this high level architecture. So I won't be providing a specific solution for our application, but know in mind that all of it falls under this category. So we have, I think, one, two, three, four, five, six. So six components in a big data system now. So we have the data source, the one I mentioned earlier. It could be a radar reading, a raster. It could be a stream coming from lightning or any source. No, it could come from NOAA. Um, and then in order for us to consume that, we need to have a system called data ingestion. So again, a lot of you are data scientists and engineers. You'd probably know data ingestion would be something like could be a batch job for those frequent run, or it could be a stream, na Kinesis stream sa AWS. You could tap on it, a pub sub system. It will be an event driven. You'll get notified, and then you consume it. So that's the general knowledge for data ingestion. And once you have the data, of course, you might want to do storage for those data, in particular for running it, say for machine learning, analytics, so on and so forth. You have to keep those data in separate component, which you call data storage. So it differs. If you have, say, a raster coming from NASA, you would save it in an S3. If it's going to be in structured, it could be an RDS, it could be a Parquet for columnar if it's a big volume, and you could run it efficiently with Python via data frames now. And that particular part, once you stored it, you handle it via the servicing component. Actually, the servicing side, that's more of the business logic side, the one you guys are working on now. So if you say servicing, it could be analytics, it could be machine learning, the loop, pipelines for business logic before you do data consumption. So data consumption would be the endpoint, meaning the user would be using it. It could be a REST API, it could be a WebSocket, so on and so forth. And there are various cases. Then for our case, is like the one I mentioned, for example, the Lightning side. If the client would like to have status right away, you might go directly from data source, data ingestion, directly to data consumption. So it happens as well now. You could provide a status to the client, and then probably later on, eventual consistency, you could store it somehow. And on top of that, we have data governance. So ito na yung security, and then of course overhead, orchestration, so on and so forth. No? So these are the main components that we have. Some might be, for example, the one I mentioned, bypassing the storage directly to data consumption. Some would be just storing it to data for later on a run for servicing. So it's a mix match of this particular system na sa big data. And I think what's important would be the data analysis now. So if we in the weather context, if you say descriptive, what happened, like I mentioned earlier, is there gonna be lightning on our current lightning condition? You would provide in this particular region, you'll be having you have a lightning ongoing now. So descriptive, what's status quo, what's happening? Diagnostic, why did it happen? In our case, if you watch the news now, so Julian was able to uh, go away na sa Philippines. It's on the top. It's actually hitting. Was it Taiwan or Japan? But we're still experiencing a lot of rain, and then the meteorologist would say that's because we have it's pulling the monsoon. No? So you'll probably hear a lot of this every end of the news. So monsoon is being pulled, and that's diagnostic. No? Predictive is the forecasting side. If you take a look at yung mga weather forecast, if there's going to be a typhoon hitting Philippines, there will be multiple routes, and that's actually the predictive route. Again, multiple models and multiple prediction. Prescriptive, this again, I would say it's more of the um, what should be done about it. No? So NOAA provides us yung red warning, orange warning, and then if it's red warning, you expect some kind of flooding in some regions. No? And it's regional. I think they're doing a great job, even posting it in social media to inform us. The last part is an interesting part because it's called cognitive. In cognitive, this is the hype now. We want to talk directly to the data. So, for example, you do this. I think you could talk to Alexa and say, "What's the weather today?" And Alexa would provide you the descriptive part, but in a way that you're like talking to the data. So that's cognitive, and I've seen a lot of data science trend nowadays. They want to talk to SQL, so on and so forth. So that's cognitive now. Um, Time check. We still have 15 minutes. Well, I'll go through these use cases. I think about 5 or 6, and that'll be quick about it now. So use cases, this is the nitty gritty, and I hopefully you could find at least some of the solution that we did, and you could adapt it to your industry. So in weather forecasting, again, this requires a lot of compute, and AWS provided us the what we call high performance computing. We did a run for Hurricane Laura, a category 4 hurricane that made landfall in Louisiana in August 2020. So using HPC, the company was able to provide reliable forecast generate high resolution weather forecast at double the frequency. So if you're wondering why does that matter, because mostly the typical running of model or forecast creation is twice a day, and we doubled that. And at a higher frequency, you could ingest more data, current data, and then you could provide much more detailed forecast and much precise na forecast. And we did that via the HPC. And then we also have, I'd like to read this particular quote from the Zach Iskal from NYC Emergency Management Commissioner. So the ability of DTN to deliver for future and real-time weather intelligence and insights on hyper-local level. So it's really important that we do granularity with that particular insight because it tailors our emergency services accordingly. Sorry, I kind of I'll tab that now. So how do we solve this particular situation now? Typically, if you use S2 and you read the grid file, for example, or the data, you would map it as square in the map. And I think one of the problem that we have is that it's not highly targeted, it's not hyper local. And Uber, again, like the self-driving car that I mentioned, it's a different industry. So if you're wondering if you're going out, especially it's traffic in Manila now, Uber or Grab, you kind of find that you have this pricing tier, different for specific region. And Uber, what they did on how to have an efficient mapping is they created this what we call H3, a hierarchical spatial index. So the middle image I showed you earlier is the usual way. You have an S2 and you read the data for all of these small boxes. It's kind of hard to see now, but it's fine grained. And imagine the amount of data coming in at a velocity, high velocity, and that's not actually ideal. So what they did is they created hexagon. They called it hierarchical Uber hexagon H3. And as you can see on the other side, the rightmost part, you could do targeting, hyper local targeting. Say, for example, in our case, if it's Makati, you don't want to have a specific reading in the Ayala Triangle, no people on that side. You could actually target just those that are actually residential, and they provide highly hyper local insights for those. And this one, so we have 2 minutes more. So this particular one is created by our colleague Alan Bill, and he won the our Q2 hackathon, and it's now productized. And some of you guys I think would have experienced, the canvas rendering in the client, the browser, and if you use yung the usual OpenStreetMap, Mapbox, and you try to provide a raster image on top, it usually just being rendered na raster, no? Parang it's like being placed on top as a layer. There's no interactivity, and if you zoom in, once again, it's a raster. It's kind of like this one being shown. It's not good. So Alan created a GPU accelerated renderer for us. It introduces anti-aliasing. Introduces interactivity. You could click on different regions and contours, and it's in browser. And you could see him doing the scrolling without any problem with his local machine. So it's purely client side now. Uh, it's exciting. We're now productizing this, and it should be used by most of the customers by hopefully by next year now. Um, Last but not the least, this I think would be the interesting side. How do we leverage AI? We've had DTN has a current partnership with Palantir. If you've heard about Palantir, one of the biggest AI company in the US, and they provide solutioning for the government, the US government, specifically for uh, the I would say just some military. No, so you might read some of the news, but you could Google Palantir and you'll see a lot of use cases they've been trying to help the U.S. government on. In our case, uh, the pipeline I've showed earlier could be handled easily by AIP, the platform that the Palantir is providing, and then we could easily share it within our group by the ontology. We could provide insights by their dashboard, so on and so forth, and it's being integrated in some of our applications now. And yeah, I think I might have been on run over time now, 151, 9 minutes left. But thank you again. Quote me on this. If you want to save lives, you could join us. I'll send the link then. And that's for my session. Anna, thank you.
Very insightful presentation. Now, are you guys ready for the question and answer portion? Let's have here Sir Armando. What are the primary sources of weather data and how do they impact the accuracy of weather intelligence systems?
Yeah, the one I mentioned earlier now. So it could be several things, but the good question is how do they impact the accuracy of weather intelligence system? So it differs to the instrumentation, but again, in our case, I'm not sure about the Pag-asa's instrument that we have, but let me try to share my screen. Uh, I think that would help as well. So as I mentioned earlier, we do have all of this specific data sources. Some would be coming from weather balloons, some coming from the satellites, so on and so forth. I would say um, some of the data sources that we have, it's kind of legacy then. Even some of the handling again, this is global thing. Some of the weather station would not be able to update their system, so it's under the fall of the government that they have on how to update their instrumentation. So the accuracy, I would say, would come in once we have a Q&A, QC filtering on our end. So if there are data sources, if you see the ingestion side of the big data, we do have validations for those. So and I do regress. There are some instrumentation that are not really good. So I think one of the way to do that is to remove, say, for example, if you have a data grid, you could remove the nullables, something like that. But in all, it falls under the ingestion and how you treat those particular data. Thank you, Armin.
Okay, thank you for that, Sir Ryan. And we also have another one from Isa. How can we overcome technological barriers here in the Philippines, such as
Mm.
limited internet connectivity and infrastructure, to ensure widespread access to weather information and services?
Yeah, that's a good one. Again, I could only assume and answer on our end as a someone working in a private enterprise and compare it to what we have in the Philippines, and it's somewhat unfortunate because we are kind of lacking, especially with instrumentation side. We don't have that much frequent reading. Even in the typhoon that we usually use yung Japan and some of the regions ng ASEAN. No, we kind of unfortunate, but I think the best answer would be to lobby and then probably provide our politicians with, this will affect us all. It's a weather, it's nonstop. We do get typhoons every year, and how can we plan on that now? It's something that is beyond us, I guess. But it lobby would be lobbying for this. You could probably shout out in social media, so on and so forth. But yeah, that works for now, I think.
Thank you, sir. That is well understood. And we also have another one from Christian. How does the system manage huge amounts of data and unpredictable factors to provide accurate real-time forecasts? What are the limitations and risks?
Parang ano ka, Miss Universe. And it's really good question by Christian. Uh, it's again, it's a big data problem. So huge amounts of data, multiple solutioning. For example, in our case, we have this particular situation. We used to have an RDS accepting most of the data, but it became too large. We now have a parquet instead for that particular scenario. So it could be a granular implementation thing, but thinking of it as an architect, you'll find kind of like you, parang nagre-review ka, you'll have a code smell on the architectural side. You'll foresee that there's going to be a problem along the way if you have a specific amount of data incoming, the volume, so on and so forth. You get to compute it. You get to have a risk assessment, and then you solution it in such a way that would be acceptable to the business side. Then, so again, in my side, I do provide recommendation, but it's ultimately it's going to be the business side who will decide on that.
Thank you, sir. And we also have another one from John. Can you provide specific examples of how weather intelligence, particularly advanced visualizations, are being used to make critical decisions in industries beyond the obvious like agriculture or transportation?
Thank you for that, John. So in our case, the one I mentioned earlier, we have several industries in the Australian region handled by Weather Zone, and two I could share is the mining industry. So in their case, it's really important for them to know what particular expected weather for this particular day, so that the workers won't be, they won't go into uh, inside the mine. I don't think it's an open pit mine, but we do have several mining industries. So that particular use case is really important for forecasting their day-to-day job. And another one would be the one I mentioned, pretty much like what we have with Meralco. No? If it's a utility worker, they really need to be notified if there's going to be a storm surge or like lightning on that particular region, just to stop them from working on the particular utility pole.
Got it. I hope that answered your question, Sir John. And another one from Rochelle. What are the cost implications of implementing advanced weather data sourcing and visualization technologies for local governments and organizations?
That's a good one. I think what we lack to measure would be the aftermath effect of most of the, for example, in our case in the Philippines, we typically have a cost for the industry, numbers of lives lost, but in the long run it actually cascades to various costs, and some people actually lost their lives even a week or a month after that particular disaster of a typhoon, no? And that's what's lacking in the Philippines. We do need, I'm calling the data scientist in our case, we really need to help the government on measuring those particular cost measures. And once they see the cost and how it affects us all in all, I think they'll really lobby for a solution on that, because it's again, it's a large cost, it's a big disaster. But yeah, that's it.
Got it. And for our last question coming from Kim, what are the key challenges in ensuring the accuracy and reliability of weather data, and how does DTN handle potential discrepancies, especially in real-time data feeds?
That's a good question. No? So that falls under mostly in the ingestion side. So right before you do the ingestion service itself, you really have some kind of negative testing. I would say it involves both the data scientists, the engineers, and the QA. They should provide a particular handling. You could do unit tests in your case, and then for the QA, they should be able to mock data that are unexpected. So those are what we call the QC, the quality checks. And you have, min max of data, you remove it, you have null, you remove it, so on and so forth. But the implementation level would fall under the team that handles the particular data. And there are, I would say, references you could look at and even in GitHub you could take a look at on how to a library that handles a specific schema. So if you're using Node.js, you could use I think it was Zod, schema validation, so on and so forth. But yeah, ultimately it should be a proper QC, and you should learn it should be a loop. Meaning, if you have a production issue, you should know how to fix it and remedy the QC side as well.
All right, thank you, Sir Ryan, for answering the questions. Now, for those who have questions, please feel free to chat with our speaker on Ermit. And that's all the time we have for this session. If you enjoyed this session, please give your rating and share your feedback about our speaker. You'll find the link in the chat box. So again, let's thank Sir Ryan by clicking on the reaction button. And please, guys, thank you so much. And please exit this session and click on to the next. Bye, everyone.